Welcome to the Algebra 2 Chapter 4 review. Okay, so we're going to go through and we're going to go and solve these together, so you should be following along on your worksheet. Okay, so remember when you're simplifying, we just want to go through and find each of the, what do they have in common. So here we're going to look through and find the greatest common factor. So for this first one, 10 is in common on the top. And they also have an x in common. So we can pull that out. And so we'd have left 2x plus 3. In your denominator, if you look at that, they share a 2. And then the most x's they share is x to the third. So if you divide the first one by 2x to the third, you'd be left with just 2x. Divide that by 2x to the third, you're left with plus 3. Okay, once you've factored it out, look for anything that can go through and cancel. So remember, those would cancel to 1. And again, you don't have to write multiply by 1. Okay, and then this one, the 2 can go into the 10 5 times with our exponents. Okay, remember, dividing exponents, you want to subtract them. Okay, and whichever one has the most, that's where they end up. So like 3 minus the 1 gives you 2, but because it would have been negative 2 if I did 1 minus 3, I would stay on the bottom to be a positive. So on the top, we would just have 5 left. In the denominator, since that 1x canceled out and one of those, we would just have x squared in the denominator. So that one simplifies to 5 over x squared. Okay, on number 2, you want to first say, look, these are quadratics, so we're going to have to factor them using 2 parentheses. But if it makes it easier for you, because these both have leading coefficients, remember we can use that method where we multiply by our constant. Then it just makes it a little easier to factor. So this one become a squared minus 5a plus 6. And down here, it'd be a squared plus 5a minus 36. Okay, just remember that when we go to finish these, we're going to have to divide by each of those numbers we first multiplied by. So let's do this one. Okay, so we're going to split it up and put an a in each. When you have a plus sign here, it means the signs match, and you always look here to see what sign it's going to be, so both minus signs. Okay, then what multiplies to 6 that adds, since both signs are the same, to 5? So that would be 3 and 2. Okay, but then we have to stop and say, oh, we need to go back and divide each of these by 3. So don't forget that step. That's a common mistake. So this one, I'm going to write it over here now that we have it simplified, is going to be a minus 1. And then for this one, this doesn't simplify anymore, but remember we don't leave it with a denominator. Any denominators need to move back to the front right there. Okay, so we're going to end up with 3a minus 2. Okay, let's go through and factor this one. So a in each. This time we have a minus sign there. Anytime you have a minus in front of your constant, then we have opposite signs. One's plus, one's minus. Okay, what multiplies to 36 that subtracts to 5? So hopefully you came up with 9 and 4. When we look right here, there's a plus sign, so it means the bigger number needs to go next to the plus. So that means the 9 goes here and the 4 goes there. But then again, we have to go back through and divide by 6. Okay, when you do that, these can simplify. So let's simplify them first before we start to rewrite them. Because 9 over 6 will simplify to 3 halves. And 4 over 6 will simplify to 2/3. Okay, then we will move that number into the front. So the 2 will come in front of the a. So it'll be 2a plus 3 for that piece. The 3 will go in front of the a, 3a minus 2. Okay, now we can look to see what will cancel out. So I see the 3a minus 2 will cancel. None of this will cancel, so we'll just leave it as 2a plus 3 in the numerator, and a, whoops, that was a minus 1, not plus, in the denominator. Okay, the next section, you're going to be finding each product or quotient. Okay, so again, you're going to start by simplifying them by going through factor anything that's factorable. Always look for greatest common factors. So like this, just have the greatest common factor. So like 5 goes into both of those numbers, so I can pull out a 5. And I can also pull out a w. That's what they have in common. So that would leave me with just one w here. And for this part, just a plus 4. In the denominator, okay, at first you might be thinking, there's nothing they have in common. But look, are they perfect squares? And yes, so this is an example of our difference of squares. So you will see things like that on the test. Okay, so if you have both are perfect squares and there's a minus sign, we can use difference of squares. This one's just written differently because most of the time we're used to seeing the variable squared and then minus the constant, but this one's not. So don't switch it. Okay, if we go to write this, we take the square root of the 16, which is 4 and 4. Okay, and we know that one has to be plus and one's minus. And then we split up the w. Okay, so don't try to switch them the other direction because that'll mess you up. Okay, when you divide by a fraction, remember you can also multiply by the reciprocal. So I'm going to change this to a multiplication sign and we're going to flip this over. So when I go to simplify these by factoring, okay, there's nothing that can factor out of a monomial, so that just stays, but I'm going to write it on the bottom now because I'm doing the reciprocal. Okay, and then I'm going to factor the top. So they each get a w. Because of the plus sign, the signs match and they're both going to be minus. And so what multiplies to 28, that adds to 11. So 7 and 4 is what you should have come up with. Okay, and now we're going to go through and see if we can start simplifying. Okay, when you are adding, order doesn't matter. So w plus 4, 4 plus w, those can cancel out. Okay, but then we see this, 4 minus w, w minus 4. Okay, we can't just cancel and it equal 1. Remember what we learned in class is if you have a minus sign and the numbers are switched, if I multiplied one of them by a negative 1, we could get it to switch the order. So when you do something like this, don't forget you have to go through and think about getting a negative 1. Okay, and I always just do the negative 1 on the top. Okay, so that's going to be a negative 1, and we can't forget that when we go through and see what's left. Okay, let's see what else we have. Because I have a 5 and a 15 that can simplify. Well, 5 goes into 15 3 times. So the 5 is gone, and this becomes a 3. And then same thing that we did up here with the x's, if I have a 1w here and I'm subtracting the 2 down there, okay, it'll give you a negative 1, which means if we leave it in the bottom, it would just be a w. So I'm going to cross off that 2, cross off that whole w. So let's look to see what we have on the top. We have a negative 1 times w minus 7. So I'm just going to go through and distribute that negative. So I'd make it a negative w plus 7. And in the denominator, I have the 3 and that w. So don't forget to look very closely at what you have left. Sometimes people start crossing things out and they don't realize what's left. Okay, if you don't like having the w in the front, you could always switch and put the 7 in the front and do 7 minus w. over 3w, and that is really the same thing. So either of those would be acceptable answers. Okay, multiplication is very much the same, except for we don't have to flip anything over. So I cannot simplify these numerators, so I'm just going to write them down the way that they are. But then let's go through and see if we can factor these bottoms. Okay, so that's a quadratic, so I'm going to need 2 sets of parentheses. So I can have an x in each. They're plus plus. And so what multiplies to 4? That adds to 4. The only combination that fits that is 2 and 2. Okay, for my other denominator, okay, you look for the greatest common factor. What's the biggest number that can pull out of both of those? And that's a 2. So that leaves me with x minus 2. Okay, now I'm ready to go through and start simplifying. So I can see that these 2 cancel. See that these 2 cancel. Okay, and remember, if everything on the top cancels, that doesn't mean it's 0. We're canceling these out, and they equal 1. Okay, so you have a 1 on the top. So that's going to be 1 over what we have left here. And what we have left is the 2 and the x plus 2. And I would just leave it like that in factored form. Okay, so then that would be your final answer for that one. Okay, going on to 5 and 6. These are finding each sum or difference. Okay, with these ones, you have to get common denominators. Let's change colors here. Okay, so what is a number that 3 and 8 can both go into? The least common multiple. And the first thing we come to would be 24. So I'm going to change them so they both have a denominator of 24. But in order to do that, whatever you change the denominator by, you also have to change the numerator. So you had to multiply both the top and the bottom by 8 on this side. For this side, we're going to multiply the top and the bottom by 3, because that's how we got 24. So if I go through now and simplify, I get 8 times 5 is 40x. 7 times 3 is 21x. And now that I have common denominators, I'm just going to subtract those denominators. And remember numerators, and the denominator just stays the same. So that's going to give you a 19x over 24. Okay, and then this can't simplify any further. Sometimes it's able to simplify, but this one doesn't. So then that would be our final answer. Okay, on number 6, okay, if you look at these, the only way to get them to have the same thing is to multiply them by each other. So like on this side, I'd have to multiply by an n plus 3 on both the top and the bottom. And on this side, I have to multiply by n minus 4 on the top and the bottom. Okay, don't worry about going through and multiplying the bottom. Just leave them in factored form. The n plus 3, n minus 4. On the top, I'm going to go through and multiply by the n's. So that'll give me n squared minus 3n. Oh, let's see. N squared minus 3n. Okay, then I'm going to do the other one. Okay, this one would be n squared minus 4n. Okay, because we are subtracting, remember it's going to subtract each of these pieces. So if I want, I can go through and I can distribute that negative to both parts. So that one's going to be a negative, this one's going to become a positive. Okay, so now I've distributed it. Now I'm just going to combine the like terms. So an n squared minus n squared, those just cancel out. And then we have a negative 3n plus 4n. Well, that would just give you a positive n. And then your denominators just stay. Okay, so then that would be your answer for number 6. I think I made a mistake in there. If I go back, that was a plus right there. So if we're plussing, then that ends up with 7n. Sorry, I was looking at my notes and I'm like, that's not the answer I got because I made a mistake right there. Hopefully you caught that. Yep, it should be 7n. Okay, on number 7, it says p varies inversely with x. If p equals 12 when x equals 4, find the value of p when x equals 48. Okay, remember that equation that we wrote. When it varies inversely, we have this equation, p equals k over x. So we're going to plug in the numbers they gave us, the 12 and the 4, in for p and x, and we're going to solve for k. Okay, so if p is 12, then we have to see what would k have to be. Okay, if we go through and solve this, I'd have to multiply by 4. So 12 times 4 equals 48. So that is what k equals. Okay, so if it varies inversely, then k is going to be our constant, the 48. So now it wants me to find the value of p. So this time I don't know what p is. I now know that k is 48, and x is going to be negative 48. And so now to solve for p, I just need to simplify that. Well, 48 over negative 48 just equals a negative 1. So your p equals negative 1. Okay, so we'll memorize this formula for the test. P equals k over x. And then you just solve for k, then plug in whatever other numbers they give you to find whichever one is missing. Okay, on number 8, it says find the perimeter of the triangle below. Remember from geometry that these mean that this is an isosceles triangle. So if it's isosceles, then this side over here also equals c over c plus 9. Okay, so now we're going back to like what we were doing up here above. We're going to be adding these all together. So in order to do that, we have to get common denominators. So let's simplify this denominator and see what we get. So I'm going to factor it to see what we have. Okay, because of that minus sign, one's plus, one's minus. Okay, what multiplies to 45 but subtracts to 4? That should be 9 and 5. So because it's a plus 4, this should be your 9, and this should be your 5. Well, notice these other ones already have the c plus 9, so the only thing they're missing is the c minus 5. Okay, notice on this one I did not go through and factor the top. We're going to leave the top alone. Okay, because I'm going to come over here, and to get common denominators, we're going to do c minus 5 for both of these. Okay, so again, we're going to leave the denominators. Okay, and we're only going to go through and multiply the tops. So the tops here would be c squared minus 5c for both of these. Okay, and because we're finding perimeter, perimeter is just adding all three of the sides together. So now we're going to go through and add the numerators and write it over that common denominator of c plus 9 and c minus 5. Okay, well, let's start with our c squareds. I have 2 of them, so I'm going to have it 2c squared. Okay, then we'll go to our c's. A negative 5c, negative 5c, positive 27c. That's going to simplify to 17c. Okay, and then our numbers, the only number I have is the negative 9. Okay, so again, here we have a leading coefficient. We want to factor this to see if there's anything we can cancel with the denominator. So if you want to take your 2 and multiply it, we would end up with c squared plus 17c, and that'd be minus 18. And then see if that's factorable. So I'm just going to move up here and factor it. It'd be c and c, again, plus and minus. And then what multiplies to 18 that has a difference of 17? Well, that's just 18 and 1. Because this is a plus, the 18 has to go here, and the 1 has to go there. But remember, we multiplied, so now we have to go back and divide. Okay, so to see what we have left, that would be c plus 9. And c, well, let's move the 2 to the front, so 2c minus 1 over our c plus 9 and c minus 5. So hopefully you can see there that those two cancel out. And so this would be my sum, the 2c minus 1 over c minus 5. All right, on the next one, graphing the function and identifying its key features. Okay, so remember, you may not just want to go ahead and plug this in. I mean, this will give you a general idea of what the graph looks like, but we have to go through and find all of the pieces. Okay, so again, just like we've been doing, you'll want to factor anything that's factorable. So let's start with our denominator down here. Okay, this is perfect squares, right? So difference is squares. Okay, so obviously the only thing that multiplies to 1 is 1 and 1. So 1's plus, 1 minus with difference of squares. On the top, the only thing I can factor out is a 2. Okay, so to simplify, these are going to cancel out. But remember, if something cancels out, then that means you definitely have a hole. And where do you find where that hole is? Remember, you take that equation that you canceled and set it equal to 0. And then you move it over and solve it. So you have a hole when x is at negative 1. Okay, so then we're going to take that negative 1 and we're going to plug it back into what is left. So if I plug it in to a negative 1 minus 1, that gives you a negative 2 on the bottom, which simplifies to a negative 1. Okay, so our hole is going to be at x is negative 1, y is negative 1. So I'm going to come over here and write that. Okay, so if you factor it and there's nothing that cancels, then there's no holes. But if anything cancels, then you know you have a hole. So I'm going to come right over to my graph. I'm going to put it in red at negative 1, negative 1. And remember, you do an open circle where there is a hole. Okay, so it means it can't go through that point. And remember, that affects your domain and your range because it cannot equal those numbers either. All right, let's move on to find the other pieces. Okay, so now we're going to look at finding our vertical asymptote. Okay, so to get the vertical asymptote, we're going to take what's left down here. I'm going to take my denominator, so whatever's left on the denominator, you set it equal to 0. We're going to move that over, x equals 1. And then again, to figure out, no, that is our equation, sorry, for our vertical asymptote. So at x equals 1. So now if you were to graph it, that's where you're going to get a vertical asymptote. So I'm going to draw that in on the graph. So at x equals 1 would be going right here. It's a good idea to always show that on your graph, okay, that you have an asymptote. Okay, now we're going to look for our horizontal asymptote. Okay, remember, to get the horizontal asymptote, you're looking at your leading coefficient, or the leading variables here. Okay, and remember, when the denominator has a greater exponent than the numerator, so this is for your horizontal asymptote, denominator is greater, When that happens, then your horizontal asymptote is y equals 0. So let's put that here, y equals 0, and let's draw it in on the graph. This is going to help us with our x-intercept, because if we have a horizontal asymptote at y equals 0, then that means we cannot have a y-intercept because it's not going to be able to cross there. So this would be none. It's not going to cross there. Okay, because at 0, it's just going to say error on the calculator when you go to plug it in. So then you can go and just find some other points that you could graph. So again, if you plug in your 2 over x minus 1 is what you would plug in on the graph. Okay, you would see what this graph looks like. Some of the other points that you might be able to graph is there's going to be a point at 2, 2 if you look at your table of values, and also at 3, 1. Okay, and then from there it's just going to get really close to that asymptote on this side, and on this side it's going up and getting very close to that asymptote. Okay, on this side we know we have that hole right there, but some other points you might graph. Okay, we have it going through about right here, and then it's just going to get very close on either side. Okay, so this is going to be solid until it hits that point. Then it's just going to get really close to that asymptote on this side and curve down and get close to that asymptote on this side. And again, you can find some of those points on your table once you've graphed this. Okay, so now let's go through and list our domain and range. And remember, the things that are going to affect your domain and range are these things right here. Okay, so the x's affects your domain. So this value and this value are going to affect your domain. So we're going to have x such that x cannot equal, and then we're going to list our two values that cannot equal, 1 or negative 1. And then for our range, we're going to have y such that y cannot equal, and now we're going to be using these two values, the 0 and the negative 1. Okay, so don't forget that the whole also changes your domain and range as well. Okay, so make sure you know how to do one of these problems because you'll see it on the test. All right, moving on to part 2, equations. Okay, so we're going to go through and solve each equation, and remember we have to also plug them back in to check to make sure that they work. Okay, so again, if we're adding, we have to have all common denominators. So that's the first thing we want to try and get. So if I look at 2, 3, and 4, if I start going to find the least common multiple, that's going to be 12. So I want to change all of these to 12. So I have to think to myself, what do I do to 3 to get 12? Well, I'd multiply it by a 4. So whatever I do to the top or bottom, I have to do the top. So that's going to be 4 times 1 is 4. To get 2 to equal 12, that would be times 6. So I'm going to multiply the top and the bottom by 6. So that gives me 6m. And then to get 4 to equal 12, I have to multiply by 3. Remember, when you have a binomial on the top, you have to multiply that 3 by both parts. Okay? So 3 times m is 3m. 3 times 4 is 12. Okay, now that we have common denominators, we can drop the denominators and just set the tops equal to each other. So we have 4 plus 6m equals 3m plus 12. Okay, I'm going to get my m's on the same side, so I'm going to subtract 3m from both sides so that those cancel. And because I took the m's over here, I'm going to subtract the 4 to this side. So 6 minus 3 is 3m. 12 take away 4 would give me 8. And then to finish solving, I would divide both sides by 3. So that means the m equals 8/3. Okay, and then you always just want to check, because if you ever have a variable in the denominator, remember you cannot have that make it equal 0. Well, if you look back at my original equation, I don't have any variables in the denominator. Okay, you could plug in the 8/3 in for those m's, and yes, this one would actually work. So always do check that they work. Okay, number 11 is one of those ones where you have to be careful what it equals, because we cannot have a 0 in the denominator. The only way to get common denominators here is to multiply them together. So I'm going to have x minus 2 on this side. And then over here, in order to get it to equal that, I have to multiply by 5. Okay, the denominators are now just going to cancel out, so I don't have to worry about them anymore. I'm only going to look at what's on the top. So we're going to do my x minus 2 times the x plus 5. And then on this side, 6 times 5 is just 30. I have to go through and FOIL this. So that gives me an x squared plus 5x minus 2x minus 10. Okay, because I see that I have x squareds, x's, and constants, this is going to simplify to a quadratic. So we got to move everything to the same side and combine like terms. So my 5x minus my 2x is 3x. And then a negative 10 minus that 30, to bring it over, it's going to give you a negative 40 to get it set equal to 0. Now I'm going to go through and factor it. Okay, because it's a minus, we're going to have 1 plus 1 minus. Okay, what multiplies to 40 that subtracts to 3? So if you think about that, it's 8 and 5. And because this is the plus, the 8 has to go by the plus, and the 5 by the minus. So that means we would have two different solutions, right? When you set these equal to 0, the first one's going to be x equals negative 8. And the second one would be x equals positive 5. Okay, always go back and check. If I plug in a negative 8 for x in a denominator, that's okay. Okay, you can have a denominator that's negative. You can have 5 minus 2. That would work as well, as long as it doesn't make it 0. So since neither one of those make the denominator 0, they are both viable solutions. So that one has two solutions. It could be negative 8 or positive 5. All right, let's look at that last problem. Okay, again, if it's factorable, we want to go through and factor it before we try to decide what's the common denominator we're going to try to get. So if I look at this one, I can pull out a c. So that would leave me with c minus 4. Okay, well that's going to be my common denominator, so I don't have to change that first one at all. So for this one, to equal this denominator, I'd have to multiply top and the bottom by c. So that's going to give me c squared on the top, and then over that c times the c minus 4. Okay, you also have to change this one. So this one, because it's a 1, I'm going to do the c times the c minus 4 on both the top and the bottom. Okay, so then I'm going to write that. Okay, now that I have common denominators, we're not going to worry about the denominators. We're just going to write the numerators and go through and solve. Okay, now I have to distribute the negative c. So I'm going to circle that. So I think I'm distributing that to both parts as I write it. Okay, so a negative c times a c is going to give me a negative c squared. And then a negative c times a negative 4 is going to be positive 4. So look at that. My c squareds are going to cancel out. And so in order to just solve for c, I'm going to add 2 to both sides. So that's going to leave me with 3c equals 6. And then I divide by 3. So those cancel. C equals 2. Okay, so just double check. If I go and plug that into either place, okay, 2 squared minus 4 times 2 is 8. So 4 minus 8, that would not give you 0. Over here, 2 minus 4 would not give you 0. So that works. Oops, I made another mistake because I didn't put my C here. Let's back up. So I'm not adding that. I need to move that over. Check my notes. Watch those mistakes. Little things, right? Okay, so instead, I'm going to move the 3c over and subtract. So that gives me c. And that gives me negative 2. There we go. Still, that's not going to make either one of those equal 0. So that is a viable solution. So c equals negative 2. Okay, so make sure you study these and you know how to do each of these types of problems because this is what you will see on the test.